Welcome and thanks for joining us. My guest today is Dr. Bobby Blumoff. He is Chief Technology Officer and Executive Vice President of Akamai Technologies.
Thanks, Tom. Thanks for having me on. Appreciate it.
And agencies deploying services of all sorts, both to their own citizens, their constituencies, and their employees, or even to other government agencies, tend to maybe look at the model of here's my server, there's the user at the other end, there's a network in between, and boom, we're ready to go. But in fact, there are lots of ancillary services, either in their data centers or at the edge, which can really enhance the delivery of service and delivery of the experience. Tell us what some of those are, what some of the use cases for them are, and how you get them baked into what it is as your delivery complex.
Sure. I think, for many years, we've really used a deployment model that was very data center centric, where we would deploy applications and ancillary services, for example, performance acceleration services, TLS offload, caching, not to mention the security stack, secure web gateways, firewalling capabilities, access identity. Lots and lots of capabilities all were deployed in the data center where the applications were. Now we've been in a phase for quite a while now of migrating things out to the cloud. And we've now got a new deployment model where we can put our applications in the cloud and we can deploy a lot of the capabilities that I just described as virtual appliances in the cloud, which has been really a big change in how we manage infrastructure and deploy infrastructure. And I think what we're seeing now is a augmentation of that model with the edge. The cloud makes sense for a lot of things, but if you look at the larger ecosystem, more and more we see that our applications are deployed in many locations, not just one cloud, maybe multiple clouds, maybe data centers, maybe offices. We see that our employees expect to be able to work from anywhere. We've been in a model now with the pandemic where people have been working from home, or a lot of people have been working from home, but even as the pandemic ends, there's a strong expectation that people can work from anywhere. And then the threats come from all over the place, can come from any number of countries, any number of locations, any number of actors. And so increasingly we see that the cloud, while it's a great answer for a lot of things, isn't the answer for everything. And there's now an augmentation of the cloud with the edge, and lots of capabilities now being deployed at the edge.
So maybe describe the architecture of this, because you have a cloud, right, and as you mentioned, multiple clouds. So you have instances of a application that does the load balancing and maybe some of the geographical latency reduction and so on. You might have a string of them maybe across the country. And I guess that's something the cloud services providers offer as an advantage. So the augmentation then occurs in each of those clouds, or does it occur somewhere between the cloud and the user in a specific location?
Right. It's generally going to be between the cloud and the user. So wherever the user might be, the edge is basically by definition, the edge is the portion of the internet that is nearest to those users or those devices or those things that are going to communicate over the internet. And the edge can therefore do a lot of the processing and a lot of the capabilities that we used to do in the data center or in the virtual data center, we can now do at the edge, where it's near the end user, where it's near the device, where it's near the attacker. And the attack is actually a really good example of this, because in the end, what you're trying to do is block the attack. And if you allow the attack traffic to get all the way to your data center or your virtual data center before you block it, well, that gives the attacker a lot of opportunity to do damage. They could, for example, take out a router that's upstream of your infrastructure. They could clog up a link that is upstream of your infrastructure and effectively take everything offline. And there's any number of other things that they could do. The approach that we've taken with the edge is we want to block that attack at the edge near the source of the attack before it can ever get anywhere near the data center or the virtual data center to do the damage. So security is one great example where the edge makes a lot of sense. You listed at the beginning in your first question a number of other examples where you might want to be caching content, you might want to be manipulating images, you might want to be accelerating, terminating TLS, any number of other capabilities. You do that at the edge, near the end user, near the device, near the attacker when we're talking about security. And that offloads the cloud and allows the system to scale much more effectively, be cheaper in the end, and also be much higher in performance.
I was going to say, yes, if you cache data at an edge device near where that user locus is, as opposed to in the cloud that you're paying for, then you don't have the data egress charges as often.
Right.
That you might otherwise have without that virtual enhancement, as you mentioned, at the edge, correct?
Yeah, it's good that you bring that up, because I think many people have in mind this idea that the edge is really all about caching. And yes, caching is a really great use for the edge, but I just listed a whole bunch more that I think for many people, that wasn't the obvious thought of why you would use the edge. I mentioned TLS termination, I mentioned app acceleration, I mentioned image management, any number of other capabilities, not to mention all the security capabilities that we really want to be deploying at the edge. And that may be a new concept for a lot of people.
And we'll get to that too, but I wanted to ask about some of the other enhancements, because many applications deployed to citizens do involve database matching, they involve imagery exchange and so forth. And one of them of the services is app acceleration. And I'm just curious as to how that might work when the app is not there. Can you accelerate an app downstream, even if it's hosted upstream?
Right. It's a great question. Because a lot of people think of, again, app acceleration as really being just based on caching. But today's world, applications are highly dynamic. Much of the content is not actually cacheable. And there's a lot of back and forth communication between the end user, or whatever device the end user is using, or whatever agent is on that user's device, a browser, an application, whatever it is. Very chatty communication between that and the actual sort of core of the application, where the state lives, where a lot of the application logic might live. So there's a lot of communication that has to go back and forth, much of which is not cacheable. So app acceleration involves actually accelerating that traffic back and forth, as well as reducing the amount of traffic that has to go back and forth. So in many cases, for example, we can terminate the TLS at the edge and then use very optimized protocols between the edge and the core application. We can use optimized routing between the edge and the core application. We can prefetch content. At the edge, we can look at the actual HTML, for example, and look at what's in there and what content is going to be fetched, prefetch it before the browser even gets around to doing that, so that the content is pre-positioned at the edge when the browser then goes and asks for it. And a whole bunch of other capabilities to boot. I've listed a few of them, but app acceleration really can be thought of as a whole suite of technologies, from protocol optimization, routing optimization, pre-positioning, caching, reuse of connections, connection multiplexing, a whole suite of technologies that all combine to accelerate dynamic and secure applications.
And because a good question then at this time is, as agencies look to various contracts, EIS and so on, to modernize their networks, and we've got this modernization drive going on in many different aspects of federal IT right now, but a lot of it has to do with the network. Can more up-to-date network topologies enhance the ability to use these ancillary services to accelerate and enhance and speed up?
Yeah, I think that's right. And I think what we're talking about is not just the network topology, but the application topology. And what part of the application logic should be executed, for example, either in the cloud or in, say, a core data center, versus what should happen at the edge. Because they're synergistic, they work together. And I do think that a traditional model, which uses, say, only a data center or only a virtual data center a la cloud is actually missing out on an opportunity to be more performant, more scalable, more cost effective, and more secure if they're not taking also advantage of the capabilities that are now offered at the edge.
And different applications do have
Right.
different qualities. Some of them are chatty, like chat,
Yeah.
for example, which more and more
Yes.
agencies are deploying to communicate with people. Some of them are, file transfer oriented, where latency and so forth is not quite as important. So perhaps the choice of the services and the arrangement of the applications depends on what it is you need from the application itself. In other words, not one size fits
That's
all here.
exactly right. And also, where does the data live? Edge computing has gotten a lot of attention recently, and I think of it as a augmentation of the traditional core data center computing model, because the general rule of thumb when you're thinking about computing is you're really best off moving the compute to the data, not the other way around, right? The other way around, which is not what I recommend, is basically backhauling the data over to where the compute lives. And that can get very expensive. It's obviously low in performance. And if you happen to also be under attack, then you're backhauling the attack traffic. And that's pretty much a big no-no. So rather than backhauling the data to the application or to the compute, edge computing says, well, let's move the compute over to the data. Now, you have to think then about, well, where is the data? And there's certainly a lot of data that lives at rest in your data center. So fine, you do the compute in the data center. You may have large databases, records. In some sense, think of that like data at rest. You've got data at rest sitting in your data center in a database. And in that case, absolutely, you want to do the compute right there in the data center or in the virtual data center. Makes sense. But if you have data in motion, well, that naturally lives at the edge. Data in motion, as in communication. You talked about a number of examples that you gave a moment ago, when devices are trying to communicate with applications, or when users are trying to communicate with other users or applications. Anytime data is in motion, that naturally lives at the edge. And if you can do the compute at the edge near that data, well, then you don't have to backhaul the data. And by avoiding that backhaul, you avoid performance penalties, you avoid cost, and also you avoid the big danger, which would be if you're under attack and you're backhauling the attack traffic in your data center and giving it the opportunity to really do damage.
Yeah, take the garbage out. Don't bring it back into your garage, I guess is a good way to put it. And
I
on
like
that
that
note,
metaphor. That's good.
all right,
Yeah.
we'll take a short break here. My guest today is Dr. Bobby Blumoff. He's the Executive Vice President and Chief Technology Officer at Akamai Technologies. I'm Tom Temin. This discussion is Making the Online Experience Work Securely, sponsored by Akamai Technologies here on Federal News Network.